Hello all. This segment is going to look at one of the important aspects of a good rotational grazing system, and that is the fence. And so here in the video you're seeing right now a high tension electric fence. This particular type of fence is by far and away the most popular kind of fencing that rotational grazers use. And the reason for its popularity is that it's relatively cheap to construct. You see it's constructed of, in this particular case, 4 strands of wire mounted with insulators on steel posts. There's a variety of postage configurations that can be used. And one of the advantages that reduces the cost of this type of fencing is the fact that you don't need a lot of posts. You have relatively long spans between posts. Here we're in a hilly terrain, and so you need a post fairly frequently, but in this particular instance we only have a post about one every 40 feet, whereas in a normal barbed wire fence or something like that you'd have one every 8 to 10 feet. So since posts are one of the biggest costs of a fencing system, the high tension fencing system significantly reduces that cost because of the need for relatively fewer posts. Let's take a little closer look at the wire itself. High tension wire, typically 12.5 gauge smooth wire, is a particular kind of wire. It's naturally elastic and has a built-in ability to stretch and spring back. Because of this ability to stretch and readily spring back, high tension fence is highly resistant to damage by livestock that may be challenging it, or by wildlife that may inadvertently come in contact with it. And so the next little segment of this video will show you a demonstration of the natural elasticity and the ability of this fence to spring back when it's put under a stressful situation. So we're demonstrating here the advantages of high tension wire. Why don't you do that one more time? You can pull that back as far as you can and let go, and it all springs right back into place. As I indicated earlier, one of the advantages of high tension fence that reduces cost is the need for relatively few posts. And so here's another example of a fence configuration that we might use. Here we have a steel post with insulators holding the 4 strands of wire, but then rather than going with another post at some interval, we can use in addition what are called battens. And so here's a batten, and then if we pan over here we'll see another batten, and then about 2 or 3 more before we get finally to the next post. And so these battens maintain the wire spacing but are not actually inserted into the ground. And so the steel posts are holding the wire up and in essence planting it in the ground so it's stable. But then in between here, these two steel posts are roughly 120 feet apart, and in between we have the battens which merely maintain wire spacing. And so you can see here as I handle this batten that it's loose on the wires, but does hold them up at the proper spacing. Just another word about the battens. You'll notice that the wires are attached loosely to the battens so that they can slide in case the batten gets moved, and they are not attached with insulators. And so generally speaking, for battens we will use pieces of oak, and that in itself is a good enough insulator that we don't need to put insulators on the battens themselves. So that also is a significant cost-saving measure when constructing these fences. Here I want to call your attention to another type of line post that we might use. And in fact, this section of fence here is on pretty level ground, and so we have line posts in this case a good 60 feet apart from one another. And there, as I've indicated before, there are lots of different options for line posts. These happen to be posts that are made out of a composite material manufactured from recycled paper waste, in particular recycled but unused disposable diapers, and so they're self-insulating. They're easy to install. You can just pound them into the ground with a normal post pounder, and then again you don't need insulators, and so you can just use wire clips to attach your line strands to them. And so again, that's a money-saving feature as well. You don't have to buy insulators. Another important feature of high tension electric fencing is construction of the end or corner braces. And so here in the video right now you see an example of a corner brace in the style it's called an H brace. And so let's zoom in here a little closer and look at one half of this corner brace. And so we have right here the corner post itself in the middle of the screen, and then over here to the left is the brace post, and then running between those is the horizontal beam which forms the H of the H brace. And then also associated with that, if you can see it here, is a brace wire which is attached here at the top of this post, and then runs at a angle down to the bottom of the corner post, and then there's a wire tensioner on it halfway in between so that we can tension that bracing wire down tight. And so what happens then is, as there is stress or pull put on the wires, which would be pulling this corner post to the left, that stress is transferred by the brace to the bracing post, and then the diagonal wire itself takes that stress and transfers it again down to the bottom of the corner post. So you get a very rigid triangular arrangement of the brace, and that takes the strain from any stresses that are put on the wires down the line of the fence. Besides the H braces on ends or corners, another approach for bracing a high tension fence is to use what's called a floating brace. And you see here in the picture right now a couple of floating braces, one right here in front of us and another one across the lane from it. And so these braces use a little different approach for bracing the fence, but nonetheless based on the concept of creating a triangle. So as we move in here a little closer, here's our end post to which our line wires are attached, and then we have a brace rail coming off of that, butting into the end post about halfway up its height, and then angling down to the ground as we move away from the end post. And then we get way out here at the end of the brace rail, you see that it is sitting on a concrete paving brick, in essence, fairly large one. Even old concrete silo staves are often used, and that supports the end of that brace, floats it, if you will, on the surface and keeps it from digging down into the dirt over time. The brace here is sitting on the end of that. You'll notice that there's a tensioning wire here as well that's wrapped around the end of the brace and held in place with a couple of fence staples. And let's follow that wire then towards the end post. It runs right along the ground. It's buried in the grass, but when we get out here, I've cleared the grass away, and you can see that wire is wrapped around the base of the end post. And then as we move out here a little further, you'll see right in here is a fence tensioning device, so we can pull this wire really tight. So now we've created a triangle again. And so as the wires apply force to the end post. That force is transmitted through the brace rail down to its end, and that force would tend to slide that brace rail in the direction of the line wires, but it can't slide because it's held into place by this tensioning wire down here at the bottom. And so we've got a rigid triangle. So most of the force from the pull of the wires on the end post is actually transferred to a vertical vector component here out at the end of the brace rail. That's literally then, that force is pushing down on this concrete paver, and that's what's taking most of the force. And if we have a good big solid piece of concrete here to float above the surface, it makes a very sturdy brace. The floating braces then have a couple of advantages compared to the H-braces. They take fewer materials, one less post in each case, so that's a fairly costly piece to buy, and also one less post hole to dig for each brace. And if you're in rocky or gravelly soil conditions, that can be a significant advantage as well. Another feature I'd like to call your attention to is the tensioning springs. So each strand of wire here has a fence tightener and a tensioning spring installed in it, and the purpose of the tensioning spring is not to add elasticity. The wire itself has an inherent property of elasticity, and that's why, as you saw in an earlier section of this clip, we could pull it and it would bounce right back. The purpose of the spring is to get the tension on the wire set at the proper level. It's called a high tension fence, but there's really not that much tension on the wire itself. The word high tension refers to the type of wire, meaning it has the ability to withstand extremely high tension and has this inherent characteristic of elasticity. But the spring here is designed to make sure that you have the proper tension on the fence, and you tighten the fence with the tightener here until the spring reaches a dimension of roughly 6.5 inches for that strand, and that gives you the proper tensioning on that strand all the way through. As you can see here, each strand has a tensioner and a spring on it. These tensioners and springs can be placed anywhere along the strand, but the most common is to place them very near the end brace or the corner brace, which you see is the case here because here's our corner brace that we were talking about a minute ago. There's a variety of insulator combinations that you can use when constructing high tension electric fences. In this particular corner brace here, we have pretty typical double-ended insulators, and so each wire strand is attached via that insulator. So as you can see, there's a strip of wire here that attaches the insulator to the post, and then it's a double-ended insulator, so we have the high tension strand, that line strand going out attached to that, so it is in fact insulated from the post. And if we go down here, you can see the rest of the insulators in this case that function in the same fashion. You'll note that the high tension fence wire itself is attached to these insulators by merely looping it through and then twisting it around upon itself. Once high tension wire is bent in a very tight radius, it will maintain itself in that radius. But if you try and roll it up into a larger radius coil, it will spring right back out and make itself straight again to a large degree. And so again, it has this natural elasticity. Another type of insulator configuration is insulated tubing, and so in this case, in this particular end brace, instead of having our high tension line strands connected via a double-ended insulator, we merely have them looped through the insulated tubing, double back on themselves, and then connected in this case, rather than using the twisted connection, we're using crimp sleeves to hold the wire to itself and create the joint. So here's another crimp sleeve located right here on this particular wire. Typically you'd put 2 crimps on each wire. Also down here you'll notice the connections that we've made here, and so we've got a bolt-on connector that's bringing current from a remote location and putting it into this second strand. And you can see down here there's another bolted connector with some insulated wires that are carrying current, in this case across our lane here to the strand of fence on the opposite side, and also across the bottom of a gate here to another strand on the other side of the gate. And so those insulated wires are buried in the ground so we can drive through them and cattle can walk over them and so forth. Another feature of high tension fencing that we need to be concerned about a little bit is wire spacing. And so this particular fence here is a 4-strand fence designed primarily for a beef cow herd with young calves that side. And so we have our bottom wire is about 1 foot off the ground, 6 inches to the second wire, then we've got 1 foot to the third strand, and then about 14 inches to the top strand. And so this gives us good coverage for a beef cow herd. The cows themselves are going to, if they're trying to get through a fence, they're probably going to primarily come in contact with the 3rd or the 4th strand, although typically the 3rd strand at about 2.5 feet above the ground, 2.5 to 3 feet above the ground, is a good level for adult cattle. And then the young calves, when they're very small, we need these 2 bottom wires because they're just going to shoot under this 3rd one. As they grow a bit, the primary deterrent will be the 3rd wire. The top wire you really don't need except for the occasional animal that's a jumper that likes to jump over fences. So it's wise to have a top wire somewhere up in the range of 3.5 feet off the ground to deter those that have this inclination to jump over the fence. This 4-strand wire, by the way, while it was primarily designed for cattle, would probably be suitable for sheep as well. We might lower the 3rd strand about 4 inches from where it currently is, and then this would be a perfectly suitable sheep fence. And if you had some sheep that were particularly prone to ducking under the bottom wires, you could help keep them in by putting another strand way down at the very bottom, just a couple inches off the ground, that was in fact grounded. And so when they try and duck under this bottom wire, the top of their head would hit the bottom wire, and the wool oftentimes insulates the current, so they wouldn't get much of a shock, but their bottom jaw would be hitting that grounded wire just below it, and they would get a pretty good jolt right through their jaw at that point, and that will deter them. Let's take a look here now at a way that we might create some gates in our high tension fence. In this case, again, in this paddock we have adolescent or mature cattle, and so we don't need a lot of strands to hold them in well. And so we've got a couple strands here of poly wire, which is heavy poly wire, which is a polyethylene plastic material with small strands of aluminum wire woven into it. The aluminum wire conducts the current, and the polyethylene forms the base of the strand and gives it some strength and some elasticity to a certain degree as well. And so our poly wire in each strand here is connected to an insulating electric fence handle, and then we have these specially designed gate clips here at the end. You'll notice that this one is connected to the electric fence, so it's hot. The fence handle picks up the current and transmits it to the aluminum strands in the poly wire. And then over on the other end here, the poly wire is merely tied to normal everyday insulators. And so this makes a very handy gate. You can very easily disconnect it and walk through yourself, or drop both of them and swing them out of the way and walk the cattle through that kind of a gate system. Okay, here's another line fence. All the fences we've looked at so far have been what we would call perimeter fences that are going around the outside of a large grazing area. That grazing area is typically broken up into smaller paddocks, and so this fence here that we're looking at now has only one strand of wire, and it's breaking up the larger area into smaller paddocks, and so it's a subdivision fence. Doesn't have to be nearly as secure. If the cattle are to challenge this fence and get through it, well, there's no big harm done. They're merely in the adjacent paddock and they're still contained. And so again, you don't need as sturdy a fence to subdivide your grazing area into the paddocks. For these adult cattle, one strand will do. If you've got some calves in there, you might want a second strand about halfway between the top one and the ground here, and typically that will effectively contain the cattle into the paddocks as we're moving them through the grazing. Here we have yet another fencing strategy. You zoom in a little bit here. This is a very temporary fence. This is called a break fence, and so it's dividing our main paddock into smaller units yet, which we call breaks. And the posts here are just step-in posts with a steel spike on the end that you can put some pressure on with your foot and push them into the ground. And then the wire is a small diameter, typical poly wire that's on a reel. Here's the reel, and so you can unroll that and spread your wire, tie it to a hot wire on the main fence to energize it, and create an effective barrier then to keep the animals contained within a smaller area within the paddock in order to get maximum utilization of the forage. When you're ready to move them in a day or so, you can drop this wire, walk them over it, have a second brake wire partway down the field, so you have one in the front and one behind. When you need to move the brake wire, you just roll it up on the reel, pick up the posts, and move it ahead to another spot later. Another extremely important piece of equipment for running a rotational grazing system is a water supply. It's crucial that we have a supply of water for the animals in each paddock or break, as the case may be. And so here you're seeing the water line, 1.5-inch black plastic line that we've strung here along many of our fence lines in order to have water available to animals regardless of where they're located. Right here, this line, in fact, is right at this point, goes underground. It's going underground then across this gate that we have right here, and then you see it's appearing here above ground again as it runs along this fence that's separating one paddock from another. And we'll take some other shots here showing some other water line installations in a subsequent clip. This 1.5-inch black plastic line laying on the surface is a very easy approach, fairly cost effective. Minor freezing won't damage this line, but obviously when we're done grazing in the fall, we have to prevent damage from winter freezing in the line. And so in the fall, when the grass is all gone, we can come in here with a big air compressor at the beginning of the line installation and open some of the risers along the way and blow all the residual water out of it so it's ready for winter time. And then in the spring we just hook up and repressurize it and we're good to go again. Okay, here's one example of a watering system. We've got a tank here with a float that operates a valve that's inserted through an opening in the bottom of the tank. It's important to have valves that have a high flow rate so you get rapid refilling. You can actually water with that kind of system. You can provide water to a high number of cattle with a relatively small and easy to move tank if you have a good high flow rate valve. Those valves are connected to our main poly water line via some risers. So here's an example of a riser. The male end merely clips into the female end. It's held in place by this bracket. As soon as you insert it, it opens a valve in there, and so water flows then through the hose and into the valve assembly on the tank, which you can't see here in this particular installation. And if you open this clip up and pull the male end out, the valve inside the riser here will close up, and you don't have to worry about any valves or running water issues and stuff like that as you're moving your watering system. Okay, here's a riser along the way on our main plastic pipe water line that's currently not in use. You see we've got this water line running right down the fence line, and so it can serve two paddocks at once. Got a paddock here to the south, and over here is a paddock to the north. And along this fence line we have actually 3 risers installed, equally spaced, which breaks each paddock then into 4 subsections. So each of these roughly 5 acre paddocks can be subdivided into 4 roughly 1 1/4 acre breaks if so desired, and have water available in any of those breaks continuously for the cattle. The last piece of equipment I want to point out here is a mineral feeder with some fly control mechanisms built into it. So if we want to supply these cattle, we need to supply these cattle or livestock with some salt, trace mineral salt, and we put that in the tub here. And then we have these canvas flaps that are infused with insecticide that rubs over their face when they go in to eat the salt to help control face flies. And then we also have the rope style back rubber here, again, which is infused with insecticide solution to allow the cattle to scratch themselves and at the same time disperse some of that insecticide repellent onto their backs as well. So this gives pretty good fly control while out on pasture, helps prevent or at least reduce some of the problems associated particularly with face flies like pink eye and so forth. So here's a shot of why we do this in the first place. Here's a group of dairy heifers and a couple of dry cows out here grazing at Farm 2, and of course these are dairy cows and heifers, so as soon as they saw me, they all decided to come up and pay a visit rather than stay out there grazing like other cattle would more likely do. In fact, here you'll notice that these cattle followed me down. As I walked down the lane, they followed right along till I got up here to the break fence. And if I wanted to move them into the next paddock, it'd be really, or in the next break, excuse me, it'd be really simple. I'd just have to drop my brake fence and they'd follow me right over it and into the next break, and we'd be good to go. So it's really a pretty trivial task to move the animals from break to break or paddock to paddock, especially these dairy animals. They'll pretty much follow you anywhere you go.